Hey, you're trying to make sense of that Monty Hall thing and your head is spinning? Well, don't you worry, child. I've got a plan for you. You have 3 doors. Behind one of them, Monty hides a goat. Behind another one, he hides another goat. And behind the remaining door, he hides a car. Monty then asks you to pick one door, and you'll get to keep whatever is behind it. Assuming that you prefer the car, we'll say that if you get any of the goats, you lose, and if you get the car, you win. We need to keep track of these goats, so let's paint one of them orange and the other one green. With 3 doors to choose from and only one of them that hides a car, your probability of winning is 1/3. Here you have a quick overview of all the ways in which Monty can arrange the car and the goats. If you choose door 1, 2 out of the 6 possible arrangements get you the car. The same goes if you choose door 2 or door 3. 2 out of 6 is the same as 1 out of 3. So this confirms what we just said about the probability of winning being 1/3. Now, after you choose a door, Monty does 2 things. First, he opens a door that is not the one you chose. This door always reveals a goat. And second, he asks you if you want to change your door choice or if you want to stick to it. If we look at how the game unfolds, these are the steps. First, you pick a door. Then you get to see where one of the goat is. Then you say if you want to switch or not. And eventually, the 2 remaining doors open, allowing you to find out if you win or lose. Let me quickly emphasize 2 things that may seem obvious about switching or not. One is that if you do not switch, your original door and your final door are the same. The other is that if you do switch, your original door and your final door are not the same. I emphasize this because it is essential to understanding the problem. If you decide to not switch, the game unfolds as it would if Monty had not offered you the possibility to do so. In this case, the 1/3 probability of winning remains unchanged. There is not much more to say about not switching. The rest of the video will focus on what happens if you do choose to switch, which is way more interesting. Before we dive into it, I encourage you to check out these statements, and for each of them, try to determine if it is true or false. Here we go. A is true, B is false, C is false, D is false, and E is true. Check out this table. It shows what happens if you choose to switch. We already saw that regardless of which door you pick, the probability that it hides a car is 1/3. There is also a 1/3 probability that it hides the orange goat and a 1/3 probability that it hides the green goat. Let's say that your original door hides the car. In this case, Monty shows you any of the 2 goats, you end up with the other goat, and in this case, well, it's a bummer. If your original door hides the orange goat, Monty has to show you the green goat. In this case, you end up with the car. Remember, Monty must show you a door that 1 is not your original door and 2 has a goat behind it. And well, showing you the car would make the game pointless anyways. Finally, if your original door hides the green goat, Monty must show you the orange goat, and in this case as well, you end up with a car. We can see that if you start with the car, you end up with a goat, and if you do start with any of the 2 goats, you get the car. In other words, what you get by switching is the exact opposite of what you would get without switching. By switching, you double your probability of winning, going from 1/3 to 2/3. The table breaks down each step of the game. It makes it easier to identify what is random and what is not. Let's look more closely at how things unfold. You have total control over which door you pick and over your decision to switch door or not. Actually, you can make these 2 decisions before the game starts, and nothing that happens during the game can force you to change any of these 2 decisions. Note that deciding to switch is not the same as deciding which door is your final door. We'll see in a minute how you get to your final door. But let us focus first on what is behind the doors. If we think strictly in terms of outcome, the only thing that matters is the difference between the car on the one hand and any of the two goats on the other hand. The green goat and the orange goat are interchangeable. Getting any of the two goats means that you lose, and getting the car means that you win. If we forget about tracking the goats for a while, this is how the table looks like. Since Monty must show you a goat and that it does not matter which one it is in terms of outcome here, there is no randomness either about how this step impacts the game. Next thing that happens is that you switch door. Here again, nothing is left to chance. Your action is constrained by which door Monty has previously opened. There is only one door you can switch to. We can now turn to the only element that randomly influences the outcome of the game. This is what lies behind your original door. You can decide which door you choose, but you have no idea what is behind it. True, you also ignore what is behind the other doors, but this is irrelevant since you do not choose them. It should be easier now to see why each of the statement is true or false. The trickiest is probably statement C, so I'm going to say a few words about it. A probability of 1/2 might appear logical, since there are two doors that are still closed after you switch, and that you know that one of them hides a goat and the other one hides a car. But we cannot overlook that the game starts with 3 doors, and that the goat that remains hidden, as well as the car, both stay where they are. If the remaining goat and the car were shuffled around after Monty opens the first door, then switching or not would not make any difference. The car and the goat would be, in this case, equally likely to end up behind any of the 2 remaining doors. And yes, in this case, your probability of winning would be 50%, no matter if you switch or not. But this is not what happens in this game. Alright, so to sum up, we can say that there is no randomness except for what is behind your original door. The dice are cast at the very moment when you first pick a door. The rest is just a succession of predictable events. Also, if you switch, which you can predict, your probability of winning the car is 2/3, twice as high compared to not switching. Well, that's it, I guess. I hope it helps, and if you like this video, you know what to do.